Hey guys, hoping all is well with everyone. So in this video, I wanted to now create a new playlist that is relative to the AMC 8 or the American Mathematics Competition practice questions and their full walkthroughs. So with the American Mathematics Competition, there is no calculator allowed, so we really want to focus on the mathematical methods, techniques, as well as even logical approaches to solving what can be some very challenging questions. So this first one is going to be determine the difference of 2009 squared minus 2007 squared. Now, this is a very common question typing in terms of they tend to use the year that the competition is taking place in a lot of their questions. So this question was probably in 2009, and they do have some a lot of reoccurring question types with these year type numbers. So right off the bat, when we look at this, it would be extremely tedious and daunting to try to square out 2009, then square out 2007, and then take the difference. It's not impossible, but it would just be very time-consuming, and you are kind of against the clock in this kind of competition situation. So what we need to do is figure out a way to make it represent 2007 2009 as a variable, so to speak. And that way we can use methods that will allow us to make the determination of this difference much more easy. So what we need to figure out is how 2007 and 2009 are related. Well, they're both odd numbers, and even more so they're consecutive odd numbers. So I'm going to try to determine a variable to kind of get things started here. So I'm going to let n equal 2007. Now, what I need to do is I need to figure out how 2009 is in relationship to 2007. Well, it's a consecutive odd number, or we can simply say that it's 2 greater than 2007. So I'm going to let the expression n plus 2 equal 2009. And then the next step, I'm going to make a substitution, make a direct substitution for each, for both the values of 2007 and 2009 with their new equivalent variables and expressions. So this is now going to become the quantity n plus 2 squared, sorry I have to use a caret for the exponent, minus n squared. Now, what this next step is going to allow me to do is use the FOIL method to expand out the binomial expression, which was the result from changing 2009 to n plus 2, which will, the ultimate goal behind that is to get rid of having to square something. That's the biggest task that we are facing right now, is that we have to square something, and it's just, we don't want to have to do that if we can find another means to eliminate that requirement. So use the FOIL method, and I'll be going over the FOIL method in just a second. Okay, so we have n plus 2 quantity squared, and this is equal to the quantity n plus 2 times n plus 2. So remember, the FOIL method allows us to use a 4 kind of step dynamic to fully expand out a binomial expression being squared. So we have FOIL. It's going to be first, outer, inner, last. And then this represents each step of the specific terms that we're going to be multiplying in each phase. So we have n plus 2, n plus 2. So first is your first terms. These are the first terms, so this is going to be n, and then n in the second term as well. So this is going to be n times n, or n squared. Outer is going to be the most outer terms in each expression, most like to the outside, so to speak. So n is going to be the first one on the left here, and then 2 is going to be the one on the right here. So 2 times n is 2n. Inner is going to be the most inner terms in the expression, so closest to the inside, so to speak. That's going to be 2 for the left and n for the right. That's going to be 2n again. Then we have last, which are just your last terms of each expression. That's going to be 2 for both of them, the first and second one. 2 times 2 is 4. I'm going to use plus 4 just for completion purposes and housekeeping. Now, what I'm going to do is I'm going to rewrite this, and I want to, again, represent it with the fact that we also have to account for that n squared in the very beginning of our problem, which again is just equal to 2007 squared, but algebraically speaking. So we have n squared plus 2n plus 2n plus 4 minus n squared. Now what I want to do is I want to clean this up a little bit. I want to make this a little easier on myself to see what I can either cancel out or combine as like terms. So the first thing I'll probably notice is that I can combine the 2n and the 2n, so I'll do n squared plus 2n plus 2n is 4n plus 4 minus n squared. And again, we see that now we can cancel out this whole squaring situation because n squared minus n squared will cancel. That's going to give us 4n plus 4. Now we have created a situation that is so much more easier to mentally calculate, because now all we have to do is evaluate the expression 4n plus 4 for n equals 2007, which is what we made as a statement in the very former part of this question. So now we evaluate. So we have 4, go ahead and substitute n for 2007, plus 4. Evaluating that is going to give us 4 times 2007 is 8,028. And 8,028 plus 4 is 8,032. So just kind of go through the steps here. This would be 8,028 plus 4 is equal to 8,032. Now, again, if you were to take the time and square out 2009 and then square out 2007 and take the difference, you would indeed get 8,032. But I hope this helps you guys out. And again, there are different kind of methods that you can take with this approach. If you guys have any that you would like to share, I'd love to hear them. But I hope this helps you guys out, and I look forward to seeing you in the continuation of this playlist as well. And as always, guys, thank you so much for watching, and take good care.